Hi there. Thanks for joining us on a Q&A edition of Space Nuts, our first one for the year. My name is Andrew Dunkley, your host, and we've got questions from Justin, who's sent us an audio question. He's talking about the space that contains the equivalent to 4 million stars in comparison to a black hole, I think. Can't remember. I don't write down enough when I write down the descriptions of questions.
You're right.
Charles...
You're right.
Fred's saying the same thing. Charles says is asking us a question about the retraction of the universe, the shrinking of it. And Dean is asking about what might happen if the sun instantaneously disappeared. What would be the effect on our solar system and our planet specifically? And Patrick has some thoughts about both the Voyagers 1 and 2, mainly the fact that the data we've put on the plaques that have been put on board the Voyagers is actually telling anyone who finds them a lie. That's all coming up in this edition of
Space Nuts.
And with us once again to decipher all of that gibberish that I just mentioned, and it's not the questions that are gibberish, it's my interpretation of them, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Your interpretation was more or less the same as what I thought when I saw them. So I think we're on the same wavelength, which is good.
Okay. Well, that's good. We might as well just hit them straight on the head. And our first question is an audio question, and this one comes from Justin.
G'day, Andrew and Fred. I'm Justin down in Melbourne. Like Fred, I'm an expat POM, and my astronomical claim to fame is that I witnessed the total solar eclipse in Cornwall in the UK in 1999. Two friends and I camped nearby and joined the crowds at Newquay Beach on that day for a lifetime bucket list event. So I have a mathematical question. I've often heard it said that the black hole at the center of the Milky Way galaxy, Sagittarius A star, is 4 million solar masses. So for comparison, what would the radius be in light years of a sphere centered on the Earth that contains the nearest 4 million stars? Thanks very much.
Thank you, Justin. Cornwall, that's where my family originated before they got sent out here. No, I think they came voluntarily. We didn't come with the convicts. We came out later. But Justin, good question. 4 million stars. What sort of space would that take up in terms of a radius in light years? I think was the guts of his question.
Yeah, so it's a little bit more subtle than that. It's saying,
I figured it might be.
if you're sitting here on planet Earth, what sort of in our locality in the western spiral arm of the galaxy, it's the Orion Spur where we are. That spiral arm that we sit in. It's really a question about the density of stars in our region. And that's something very well established because we know the distances of lots of stars. So I'm going to put it in much rounder figures. But if you look at out to 1,000 light years, okay, so you've got a sphere of radius 1,000 light years, then that's going to have something like 10 million stars in it.
Whoa!
So that's more than what Justin's talking about. But the way this changes, it changes non-linearly. So I'm guessing, so I'm going to take a guess that, around 900 light years or thereabouts, you would probably have something like 4 million stars, which is the same mass as the mass of the supermassive black hole at the center of the galaxy. So it's actually quite a long way. You're looking out, several hundred light years in terms of radius. It's actually, I think you would probably be able to find a tool online. I haven't found it myself because I haven't really looked for it, but I bet you can find a tool that gives you the exact answer to that, how many stars are within a radius of X number of light years. And if you put in a good guess of light years, you'll probably get the right number of stars.
Do you want me to test it?
Yeah, if you can find one. Yeah, have a look.
I've got an idea. So what's the question? How many stars in
Say within 900 light years.
okay.
See what it is. This is a guess on my part.
Radius of 900 light years. Okay. Let's see what happens here. I'll just make sure I ask the question correctly. Nothing. Oh, here we go. It's saying 10 to 15 million.
Yeah, which is different from the calculation I saw, which is 10 million in 1,000. So
Yeah.
drop it down a bit. Can you put it down to 500 light years? See what it says for that.
Okay.
This is AI, I assume, that is doing all this for you on Mr.
I love
Google.
it. I absolutely
Google.
love it. 2 to 2.5 million stars.
Yeah, so it's somewhere between 500 and 1,000 light years.
There you go.
So you put in whatever number you like and it'll give you the right answer. Justin can have a lot of fun doing that. It's a great question, actually.
I'm just working out the averages. So 750 light years transposes to 7 to 8 million stars. So, yeah. There you go. You could do this all day, really.
I don't think we've ever been asked that before.
No, I don't think so either.
Not in that way. We have had questions about, the density, the average density of stars in the solar neighbourhood, and that's really what this is all about.
Yeah.
Good stuff, Justin. Thank you for your question, and greetings to Melbourne. It's 42 in Melbourne today, I think.
Yes, we've got 38 here today. I went and played golf in that this morning, and what's the word I used? One of my friends used to use a lot when he was tired. I was jiggered by the end of it.
Jiggered, that's a
jiggered.
good word.
I don't know where it comes from.
My granddad used to use that.
Yeah.
Yeah. Wheel it in, it's jiggered.
Yeah, it was a tough day out, I must say. Thanks, Justin. Our next question comes from Charles, but because I've been using ChatGPT to solve all the riddles of the universe, I've lost the question. All right. If the universe does cease expanding and retracts, does that mean the lifetime of the universe goes from untold trillion beyond trillions of years, or just a measly few billion? This one comes from Charles in Brooklyn in New York. I was in Brooklyn not so long ago, walked across the Brooklyn Bridge.
Yeah,
good stuff. In about August it was.
Were you jiggered when you got to the end?
I was jiggered before I started because we've been walking all day.
Yeah, I can imagine. I think Charles is right, actually. Look, it may still. I mean, the difference is really that if we have a universe which is dominated by a constant dark energy term, in other words, something that puts more energy into the expansion of space as space gets bigger, that means it will go on expanding forever. So Charles has summarised that by untold trillions beyond trillions, which I guess is forever. But if the dark energy is reducing, and that's certainly being hinted at by the latest observations, then we don't know what's going to happen, because we don't know how quickly it's reducing and whether it may even go negative, so that suddenly there's a positive attraction of stuff. It's not being repelled like it is now. That could bring it down to a few billion years. But if it just settles back to something where it's the normal gravitational content of the universe that dominates everything, and so, in other words, all the galaxies are pulling each other together, then you might be talking about a bit longer. It might still be a few trillion years rather than a few measly billions. But interesting question, a nice thought experiment there from Charles in Brooklyn.
Yes, indeed. And as you said, the theory about, like, I think I've said it before, when I was growing up, it was always assumed that the universe would stop expanding and then start sort of folding back in on itself. The big crunch, or the Gnab-Gib, whatever you want to call it. But then it was decided that it was going to continue expanding at an accelerating rate. Now they've decided, and that could lead to a big rip, but now it's looking more like the acceleration is slowing, and now all the bets are off, and we're back to square one or something. I'm not sure. It's how do you prove it?
Well,
I mean, you can measure what's going on. I guess, yeah.
And that's the trick. I mean, if we'd been having this conversation a year ago, we'd have been completely sold on the Big Rip because there was nothing to suggest that the expansion was going to slow down. The expansion was known to be accelerating. That was discovered in 1998. But it's only within the last year with results from a project called DESI, the Dark Energy Survey Instrument, I think is the right thing. But that's basically established that, established is the wrong word. It has suggested that the acceleration is slower now than it was a couple of billion years ago.
Yeah.
And that is leading people to the hint that maybe the acceleration will eventually not be there. And that's why we might get the Gnab Gib. But I think we're still talking about, really think it's trillions of years into the future.
It's like blowing up a balloon, though. When you start, it goes out fast, but as it gets bigger, the expansion continues, but it slows down. It's the same thing.
Okay.
Maybe not. It does remind me, we got a question in German the other day because apparently now what they're doing on YouTube, the people who listen to us on YouTube, is it's now English-speaking YouTube podcasts are being translated into other languages. So apparently we were being heard in German, and a German listener on YouTube sent us a question in German, and we had to translate it into English so that we knew what he was asking, but I don't think it translated very well. But it was something about how do you prove the expansion of the universe if you haven't found a particle?
Well, I wasn't sure whether I did look at that question. In fact, I did send an answer, which I think Hugh might have put through some language mangling system to give the answer in German. Mein Deutsch is sehr crap. So that's K-R-A-P-P. It's not. I think I wasn't sure whether it was somebody talking about dark energy or dark matter.
Yeah, I wasn't sure either.
But dark matter, yes, we do need to know what the particles are, and I hope we'll discover them. I'm not optimistic we're going to find that out during 2026, but you never know.
Yeah, anything's possible. Thanks for your question, Charles. This is Space Nuts Q&A edition with Andrew Dunkley and Fred Watson. Now let's take a break from the show to tell you about our sponsor, NordVPN. Now I think we'll all agree that exploring the universe is thrilling, but exploring the internet without protection, that's a black hole you don't want to fall into. Sorry. As a Space Nuts listener, we have an exclusive deal for you so you can stay protected, and that is NordVPN. It's the fastest, most secure way to browse the web. With NordVPN, you get next-level encryption, blazingly fast servers around the world, and zero tracking, so you can stream, shop, or scroll safely. It's the tool I personally trust when we're diving into the internet, and we want to give you peace of mind. I've used it overseas several times. I've used it at home. It works, and it is seamless. Head to nordvpn.com/spacenuts for an exclusive deal just for Space Nuts listeners. Big savings plus 4 months extra, absolutely free. Don't surf the cosmos unshielded. Secure your digital universe today with nordvpn.com/spacenuts, and don't forget their 30-day money-back guarantee. Go to nordvpn.com/spacenuts.
3, 2, 1.
Space Nuts.
Next up, we've got Dean, who's got a kind of a what-if question for... I love these, Fred. These are my favourite questions. What if this happens?
Hi, Fred and Andrew. This is Dean in Redcliffe in Queensland. Thanks for answering my previous questions. Today, I'm asking about a thought experiment that was once used to consider issues around the speed of light. I think it may have been Einstein. The scenario asks, what happens if our sun suddenly disappears And would the sudden lack of gravity affect the Earth instantly, or would there be a delay if the gravity effect travels at a particular speed? Before I get to my actual question, I want to ask about thought experiments. They seem like a useful tool to get started on a problem, but I question the value of an experiment where the initial proposition isn't possible. The mass of the sun can't actually just disappear, so maybe basing conclusions from this is not reliable. What are your thoughts? However, if I just focus on the idea of the sun disappearing, I'd say that gravity is not a force generated by the sun, but is a compression of the space-time around it. If the sun disappeared instantly, then space-time would decompress back to a smooth state, except for the planets and moons still in the vicinity. There would also have to be an unwinding of the frame dragging around where the sun was. Let me know if I'm wrong, but it seems to me that a sudden decompression and unwinding of some local space-time would be violent, but would not be instant. Imagine the 2D model of this using a large rubber sheet with a heavy ball in the center representing the sun. If you suddenly remove the ball, then the warped sheet would snap back into a flat plane, quickly but not instantly. As space-time is very stiff, maybe the Earth would start to feel some effect very quickly, but there would be a smooth transition to the complete lack of sun's gravity while the local space-time is settling into a decompressed state. I also expect there would be a compression wave, i.e. a gravity wave, generated from an event like this. What do you think?
There's a lot packaged into that. Thank you, Dean. So there's a question, or two questions effectively, that he's asking about. What's the worth of thought experiments? Now, yeah, I just did a little bit of research while I was listening to him, and to give you an idea of thought experiments, there have been many famous ones over the years. Schrodinger's cat, Galileo's falling bodies. There's one called the trolley problem. I have to look into that. Don't know what that one is, but yeah, they have been very helpful over the years. I do think there is worth in thought experiments. It's a way of exploring something that we can't solve yet because we haven't got the technology to solve it. But it gives you something to work with, and it tosses around ideas that may provide solutions. It's I think I love the concept. I think it's very valuable. It's how we start making inquiries with thought experiments. If we didn't use our imaginations, then we probably wouldn't solve anything.
Exactly. A great answer, actually, Andrew.
Thank you.
I'll just go home and forget about it. But no, I entirely agree. The one that came to my mind was a thought experiment that had the real experiment been carried out, physics would have ground to a halt very quickly. And that's Einstein's musing in 1907 about what would happen if he jumped off the top of the patents building in Bern, which is where he was working at the time. He was a patents administrator. And so he imagined himself jumping off the top of the building. So if he carried that out as a real experiment, that could have been the end of a lot of really good stuff.
Yeah.
But what it gave him was the inspiration to define what we now call the principle of equivalence, the fact that acceleration and gravity are, to all intents and purposes, the same. And the fact that you're accelerating towards the Earth cancels out the Earth's gravity because the two are exactly equal, and that's why as you jump off the building, your pipe floats out of your mouth. If you've got money in your hands or something like that, it just floats away. You can actually demonstrate it very easily on a trampoline,
yes,
without jumping off buildings. But it was that thought experiment that led to the principle of equivalence, which told Einstein that gravity is actually a geometrical problem rather than something entwined in physics. We know it is. We still don't really understand the physics of gravity, but the geometry works so well in the general theory of relativity that the principle of equivalence has been demonstrated to be accurate to within 1 part in 10 to the 18 or something. I can't remember what the latest thing is, that it does work very, very well indeed. So yes, thought experiments are great. Now, the thought experiment regarding taking the sun 10 out of the solar system is very well established as to what happens. The Earth feels nothing for the first 8 minutes because gravitational energy travels at the same speed as light. And once the message that there is no gravitating body in the center of the solar system reaches the Earth 8 minutes after the sun has gone, the Earth just carries on in a straight line. So that's well understood. So I think Dean's thinking about the two-dimensional idea of the gravity well, which is a great way of thinking of the way mass distorts time. We're used to thinking, okay, you've got a rock in the middle of a trampoline, it's pulling it down. You take the rock away, the trampoline just springs back. But actually, it wouldn't. The space-time would take time. Basically, the message that it had sprung back would travel outwards at the speed of light, and so it's the same thing. Looking at it either as a gravity well or as gravitational energy or radiation. Yeah. One day we'll have a quantum theory of gravity, and we'll be able to talk about gravitons, which are the hypothetical particles that carry gravity, and they move at the speed of light.
Of course, we should mention the catastrophe that would then follow 8 minutes after the sun suddenly disappeared.
Yes.
For example, Pavlov's dog and Schrodinger's cat would live together.
Yes. So they would. Yeah. Oh, dearie me. That's, yes.
It would be a mess.
How
long would the Earth last after that effect?
It would be fine. It would just keep on going. Assuming there wasn't some sort of catastrophic event that caused the sun to disappear. If you just remove the sun without anything explosive or anything, which you can do in a thought experiment, the Earth just keeps on going. It would be like Voyager 1 and Voyager 2. It will get very, very cold. We as a species would almost certainly not survive because the temperatures would plummet to very low levels indeed. So, yes, an interesting scenario.
Doesn't sound like much fun.
It's not fun, no.
No.
It's fun to think about it, though.
We're stuck with the sun for several more billion years.
Yes, indeed we are.
Yeah. But great questions, Dean. I really enjoy those kinds of questions. So, thanks for sending it in.
Let's take a break from the show to tell you about our sponsor, Anti-Gravity A1. Have you ever wished you could actually feel what it's like to fly? Not just control a drone from the ground, but truly experience the air around you. Well, that future has just arrived. Introducing the Anti-Gravity A1, the world's first all-in-one 8K 360 drone. And it's officially available now. This isn't just another drone. It's an entirely new category. The camera is unreal. Anti-Gravity A1 captures 8K full 360-degree video on every flight. No missed shots, no worrying about gimbals or lining up angles. Just fly first, frame later. You can create cinematic pans, add special effects, or achieve perfectly stabilized action footage thanks to the flow state stabilization. And the whole drone weighs in at just 249 grams. That means travel ready, regulation friendly, and it fits in the palm of your hand. The Anti-Gravity A1 is now available in 3 bundles at the Anti-Gravity store, Best Buy and authorised retailers worldwide. So if you ever wanted to rethink what a drone can be or what flight can feel like, check out the Anti-Gravity A1. Just tap on the link in the show notes.
3, 2, 1. Space nuts.
Our final question today comes from Patrick. He's a conspiracy theorist. Well, he's probably not, but I do like this question because I didn't know this. The Voyager spacecraft have plaques on them. I did know that. And as far as I can find out, both show them leaving the solar system ecliptic between Jupiter and Saturn. That didn't happen. And from what I've read, Voyager 1 left after a visit to Titan, while Voyager 2 carried on. Voyager 1 had a chance to visit Pluto. So here's the questions. Why does the plaque show an early departure of Voyager 1, and why does Voyager 2's path show the same? Hope you both had a wonderful Christmas, and hello from a wet Northern Ireland, Patrick. Wet Northern Ireland. It's probably still wet, just like we're still dry. We've hit the hottest, driest part of the year in Australia, and it is dry as a chip, as we say in this country at the moment. Okay. I didn't realise that the plaques had the supposed path of both spacecraft, but they didn't go that way. Did they get pulled over by an RBT, perhaps?
I thought you'd have spotted this one right at the start, Andrew.
Really?
Yeah.
Is he playing us?
No, he's got his spacecraft mixed up, because it's the two pioneers that show the spacecraft leaving the solar system between the orbits of Jupiter.
I never even thought of that.
The Voyager doesn't actually have a diagram like that on it. It's got mostly diagrams how to play the golden record.
That's right.
So it's the Pioneer spacecraft. So Patrick, your question's a good one, but I think the premise is wrong. It's not the Voyager spacecraft that had the diagram. It's the Pioneers.
Well, how about that? Yeah, I'm just looking at them now. Okay. That's and it's got the human being on it.
Yeah,
and all that.
I actually really like the Pioneer plaques. I think they're elegant and decorative and tell the story. Just show aliens just how chewy we are, and how tasty we might be,
and how unfortunate that male appendage is. It's well below par. But and the other factor is that
thanks, Andrew.
Aliens will look at these two human figures and they'll go, "She does not like him."
That's right.
The body language is not positive.
That's true. There is body language on there that really, I'm with you on that, actually, Andrew. It's all about body language. Yeah.
So now I'm going to have to look up what the Voyager plaques look like.
Yeah.
See, it's the golden record with the
all sorts
bits and bobs on them.
Stuff on it.
Yeah. Okay. So, right idea, wrong spacecraft is basically the answer to the question.
I think that's correct.
So,
and look,
I think we could safely say that Voyager 1 and Voyager 2 did go where we intended them to.
Yes, they did.
Go.
Yeah.
And they're still going.
Yeah, indeed they are. Voyager 2, well, Pioneer 10 and 11 are as well. Voyager 2 was the one that flew by Uranus and Neptune, as well as Jupiter and Saturn. Fantastic details that came from those two spacecraft. Voyager 1, as we've said many times before, is the most distant human-made object and is still on its way. It's almost a light day away. We should have a little party at Space Nuts when it crosses a light day, the light day boundary.
Yeah, which is happening in about 500 years from now. No, I'm not sure.
Can't
be that far away.
Yeah, it's a few years. Yeah, a couple of years, I think. It's about 23 light hours at the moment. So it'll be, it's 4 or 5 years.
Yeah, wow. Yeah, I thought we should do something special about that.
Should do that, yes.
All right. Well, that was easily solved. Thanks for the question, though, Patrick. It sort of, it reminds us that as time goes on, you can sort of mix two totally different things together, and it throws your brain out. It reminds me of a story once where, a guy I worked with in radio did a special about Dean Martin and Jerry Lewis getting back together. Remember them? Yeah, but he thought it was Jerry Lee Lewis. And so he did this whole special with Jerry Lee Lewis music. And it was completely wrong.
Yes.
But it can happen.
It can happen. Yeah. I looked at some research recently where they'd got the wrong telescope.
Well, it's like getting the colour of the universe wrong when you make
That's another one. That's correct, yes. Yeah.
Oh, there's a list of them. So don't feel bad, Patrick. It happens to the best of us. Yeah. But thanks for the question. Lovely to hear from you. If you've got questions for us, please send them in to us via our website. Just go to spacenutspodcast.com. or spacenuts.io if you're a lazy typist, and click on the AMA button up the top, and you can send us text and audio questions that way. We sometimes get them through YouTube, so if you're a YouTube listener, please send them in. Be happy to hear from you. And don't forget reviews. We really appreciate your reviews. The more reviews, the better. I mean, it's an astronomy podcast, so 5 stars would be the absolute minimum, I would expect. That's up to you. No influence here.
4 million stars.
4 million stars?
Yeah,
yes,
yeah.
Deal. If you'd like to do that for us, that'd be great. And don't forget to check out our website. If you want to support us, some people do through Patreon and Supercast. There's a little button where it says support our podcasts. So click that button. You can find out more about it. It's totally voluntary. Fred, we are done. Thank you so much for answering those questions.
It's a pleasure. It's always good to interact with our 4 listeners.
Yes. We've only got 4 at a time. Yes.
Yeah, no, it's good. And thank you very much again, as always, Andrew, for being the host of Space Notes.
Oh, my great pleasure. It's good fun. Professor Fred Watson, astronomer at large, he'll join us again on the next episode. And Hugh in the studio couldn't be with us today because he was doing a thought experiment where he didn't exist. What more can I say? And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.